equation. Then also we have proved the Euler special condition 1, that is if a function is independent of y. Now today we shall discuss the second Euler special condition second, that is a function is independent of x. If x is absent, then we have to write. Okay. So this is the last part of unit 3rd. We have to check. Now see here, the functional Euler equation for the functional j of y of x, which is equals to integral from a to b f of x comma y dash dx, has a extremum if the Euler equation satisfies dou f by dou y minus d by dx of dou f by dou y dash, which is equals to 0. So f suffix y minus d by dy dx of f y dash. Here the given function is function of x comma y dash. Okay. Then here these are the remaining notes you have already studied. This is the fundamental theorem of calculus. Now we have to discuss the Euler's condition, Euler's special condition. And this is the Euler's special condition second. What is that? That is a case second. The function is independent of x. You know that the Euler's function is, which is in terms of independent of x, the functional we have the functional is j of y of x, which can be written as integral from a to b f of x comma y dash. Here the function is of x comma y dash. Now suppose the functional is, when the function, this is given functional which is in the form of x comma y dash. If the function is independent of x, then we can write j of y of x, which is equals to integral from a to b f of y comma y dash dx. Here the function is in the form of y and y dash. Here in the function is in the form of y and y dash. So we have given f which is equals to y comma y dash. We have given the function which is independent of y comma y dash, that is f of y comma y dash. Now we know that the Euler's equation, we know that the Euler equation is, how we can write, Fy minus d by dx of Fy dash, which is equals to 0. So we can write this as F suffix y minus d by dx of, आता पहा, Fy is a function of, here Fy dash, and Fy is a function of y comma y dash. So if we take the d by dx of Fy dash of y comma y dash, then we have to take the partial derivative. How we can take here? Its partial derivative is Fy dash. This is a given function. Now we have to take the partial derivative with respect to y. Partial derivative of y. So असंच आपल्याला into dou y by dou x, याला वाटलं तर मी सविस्तर लिहितो. So we can write this as, आता याला आपण लिहितो dou Fy dash divide by dou y into dy by dx plus, याचं कसं डेरिव्हेटिव्ह येतो पहा, d by dx of Fy dash of y comma y dash, which is again a function of y comma y dash. So dou Fy dash by dou y into dy by dx. If we differentiate this with respect to x, plus dou Fy dash by dou y dash into dou y dash by dou x. This is the derivative of this function. याला वाटलं तर मी इथं लिहितो असं, dou Fy dash divide by dou y into dy by dx plus dou Fy dash divide by dou y dash into dy dash divide by dx, which is equals to 0, because f is a function of y comma y dash here. F is a function of y comma y dash. So we have to differentiate this Fy dash, which is a function of y comma y dash, with respect to x. Then we have to take the partial derivative dou Fy dash divided by dou y into dy by dx plus dou Fy dash divided by dou y dash into dy by dash divided by dy. म्हणजे इथं हा जो फंक्शन आहे ना, Fy dash is again a function of y and y dash. तर सुरुवातीला y न घ्या, नंतर y dash न घ्या. समजलं का रे हे स्टुडंट्स? हे समजलं का डेरिव्हेटिव्ह कसं घेतला? एवढाच पार्ट थोडा किचकट आहे. सो Fy minus, we can write Fy dash into y dash plus Fy dash into y dash into dy dash by dy dash म्हणजे y double dash, which is equals to 0. हा 0 झाला. हे समजलं ना, हाच थोडा पार्ट महत्वाचा आहे, हा समजणं महत्वाचं आहे. मग आता इथं if we take the minus ना मल्टिप्लाय करा. So Fy minus Fy dash into y dash minus, इथं परत Fy dash into y double dash, which is equals to 0. So this is derivative Fy. this is also derivative Fy. Then we can take, आता हा जो product form आहे, this can be written commonly d by dy of Fy, means d by dy, we can write F minus हा product आहे, product rule आहे, y dash into Fy dash. याचा जर डेरिव्हेटिव्ह विथ रिस्पेक्ट टू y घेतला, शॉर्टली वी कॅन राईट दिस. This is the expansion form. If we can write, this is a product rule. has जो second part है, this is a product rule of dy by dy of Fy dash. So we can write taken dy by dy of Fy ला f लिहिता येतं मायनस दिस. आणि एखाद्या फंक्शनचा डेरिव्हेटिव्ह जेव्हा 0 असतो, d by dy of this function is 0, then we can say that this is a constant. So we can write, ह्याला आपल्याला constant लिहिता येतं. So we can say f minus y dash into Fy dash, which is equals to constant. इथं नोट कारण द्या, derivative of, suppose f of x is equals to 0 असतो, this implies that f of x is equals to c. Same way, d by dy of this bracket is 0, then we can say that this bracket is constant. So f minus y dash into Fy dash is equals to c. This is the required condition for the function, required condition for the Euler equation, for the Euler equation of the function which is independent of x, which is independent of x. y डबल डॅश नाही आहे, y डबल डॅश नाही. आता याचा जर डेरिव्हेटिव्ह तुम्ही मध्ये घेतलात, d बाय dy जर कॅल्क्युलेट केला, तर हा कॉमन y डॅश काढला होता ना, y डबल डॅश होता ना, y डबल डॅश मधला y कॉमन काढलेला, एक डेरिव्हेटिव्ह कॉमन घेतलेला आहे, म्हणून डबल डॅशच्या जागी सिंगल डॅश झाला हा. सी दिस, y डबल डॅश होता तो y डॅश झाला, y डबल डॅश होता तो y डॅश झाला, कारण dy बाय dx आपण कॉमन काढलेला आहे. म्हणजे आता ते प्रोडक्ट रूल वापरायला, सेकंड इज इट इज डेरिव्हेटिव्ह ऑफ फर्स्ट मायनस फर्स्ट इज इट इज डेरिव्हेटिव्ह ऑफ सेकंड, म्हणजे ही टर्म येते. सी दिस कंप्लीट टर्म इज हियर. हा आहे टोटल टर्म, म्हणून y डबल डॅश नाही आहे. y डबल डॅश मधला एक dy बाय d बाय dy कॉमन काढल्यामुळं y डबल डॅशची व्हॅल्यू y झालेली आहे, म्हणून डबल डॅश येत नाही. हा, या केसमध्ये डबल डॅश येत नाही. ओके, नाउ वी शॅल सॉल्व द प्रॉब्लेम बेस्ड ऑन दिस. आता याच्यावरचे आपल्याला प्रॉब्लेम सॉल्व करायचे. तर ऑयलर इक्वेशन नोट मी परत एकदा लिहितो. नोट, first, if j of y of x is equals to integral from a to b f of x comma y dash then dx. Then Euler equation is काय येतं रे सांगा बर, एफ वाय मायनस डी बाय डी एक्स ऑफ एफ वाय डॅश which is equals to 0. Now Euler special condition 1 means the functional is independent of y if j of y of x which is equals to integral from a to b f of x comma y dash dx means this function is independent of y. सांगा बरं याचा Euler equation काय येतं, then Euler equation is काय असतं सांगा, then fy dash which is equals to c. fy 0 असतो, fy 0 असतो म्हणजेच fy dash which is equals to c. And third means Euler special case second, if a function is independent of x means y comma y dash dx, then now we have proved this, आता आपण प्रूव्ह केलेलं आहे. then Euler equation is what is that Euler equation? We have proved f minus y dash into fy dash which is equals to 0. This is the Euler second condition, this is the Euler first condition, this is the Euler generally which is equals to 0. Now आता याच्यावरचे प्रॉब्लेम्स घेऊ. We shall discuss the problem. काल जो आपला प्रॉब्लेम होता ना, काल आपण अर्धवट सोडवलेला तो प्रॉब्लेम घेऊ. तो या केसमध्ये येतो, या स्पेशल केसमध्ये येतो. फर्स्ट फाइंड द एक्स्ट्रीमल ऑफ द फंक्शनल functional equation j of y of x which is equals to integral from x0 to x0 to x1 1 plus y square divided by काय होतं रे y dash square dx. See this is the functional which is independent of x because in that function there is no any x is absent, that means independent of x. Then we have to use this Euler special condition second, Euler special condition second to solve this functional. आता हा functional solve करण्यासाठी Euler special condition second वापरायचे आणि या ठिकाणी इंटिग्रल चे लिमिट x0 to x1 आहे, that means from a to b. Again y is a function of x, x0 to x1 means y is a function of x. So we have to calculate here y and y dash are the functions of x because the integration is with respect to x. Now we can solve this. Answer: given functional is j of y of x which is equals to integral from x0 to x1 1 plus y square divided by y dash square into dx. Here f of y comma y dash, which is equals to 1 plus y square divided by y dash square. This function is independent of x, so we have to use Euler special condition second. What is that special condition second? F minus y dash into fy dash is equals to 0. F minus y dash into f. See this. We shall take the partial derivative with respect to y dash. So we can write, 1 minute. So we can write fy dash, which is equals to fy dash y comma y dash, which is equals to this constant coefficient is it is y square into power multiple मध्ये घ्या, power 1 न कमी करा, म्हणजेच -2 into y dash power multiple मध्ये power 1 ने कमी, x raised to n चा derivative n in x raised to n minus 1, so it will be -3. Therefore we can write f suffix y dash, which is equals to minus, okay, very good, 1 plus y square divided by, हे 2 इथं घेतो, 1 plus y square divided by, कसं होतंय रे, 1 minute, पॉवर मल्टिपल मध्ये मीन्स -2 into पॉवर 1 न कमी मीन्स y dash raised to -3. बरोबर आहे का रे? आता पॉवर मल्टिपल मध्ये पॉवर 1 न कमी, सो वी कॅन राईट fy dash, which is equals to -2 into 1 plus y square divided by y dash raised to 3. Suppose this is equation number 3. Put into, आता 2 मध्ये ठेवा, 2 मध्ये ठेवल्यानंतर काय होतं, f minus y dash into fy dash, which is equals to c. Put the value of f. F means what? 1 plus y square divided by y dash square. 1 plus y square divided by y dash square. This is the value of f, minus y dash into, put this value, y dash into fy dash means from 3 minus 2 into -2 × 1 plus y square divided by y dash raised to 3, which is equals to 0. Is it okay? Now this y dash square and y dash cube will be cancelled. 1 plus y square divided by y dash square minus plus 2 into 1 plus y square divided by, okay करे students, आता y dash square, which is equals to 0. Now we can take the LCM. आता LCM घेऊ शकता. LCM काय? y dash square. So we can take y dash square is equals to 1 plus y square plus 2 plus 2y square, which is equals to 0, sorry, which is equals to c, which is equals to c आहे ना, विसरलात का? हा, व्हेरी गुड सौरव वाडे. पा कॉन्सन्ट्रेशन कुणाचं आहे काय नाही लक्षात येतं मला. विनाकारण हो हो म्हटलं तर चालणार नाही, इथं चुकलं, रॉंग जरी झालं, you are saying correct, then I understand that your concentration is not on the board. Okay, is it okay? So next we shall discuss 1 plus 2 means 3y, 3 plus 3y square divided by y dash square is equals to c. So 3 in a bracket 1 plus y square divided by y dash square, which is equals to c. So we can write this as, आता याला solve करा, 1 minute. So we can write this as 1 plus y square divided by y dash square, which is equals to c divided by 3. Reciprocal घ्या आता. So y dash square divided by 1 plus y square, which is equals to 3 by c. Okay. आता 3 by c आहे, त्याला कॉन्स्टंट कन्सिडर करू, स्मॉल c. Therefore y dash square divided by 1 plus y square, which is equals to c1. We consider since c1 is equals to 3 by c. आता square root घ्या by taking a square root. So y dash square is equals to c1 into 1 plus y square. Square root घ्या by taking a square root. So y dash is equals to root of c1 into 1 plus y square. So y dash is equals to root c1 into root of 1 plus y square. That means dy by dx equals to root c1 into root of 1 plus y square. So we can write, आता व्हेरिएबल सेपरेट करा. Variable separate करा. Y dash means we can write dy by dx. So it will be dy divided by root of 1 plus y square, which is equals to root c1 into dx. Same, separating this variable because we have to take the integration. So by integrating, it will be, by integrating, आता याचं इंटिग्रेशन घ्या. इंटिग्रेशन घेतल्यानंतर काय येतं पहा, इंटिग्रेशन ऑफ dy divided by root of 1 plus y square, which is equals to root of c1 into dx. c1 is the constant. So 1 upon 1 plus x square or x square plus 1. There is a standard formula. That standard formula is sin h inverse of, so sin h inverse of y, which is equals to root of c1 into dx integration x plus c2 plus this is a constant of integration C2. वाटलं तर इथं फॉर्म्युला लिहा, integration of dx divided by root of 1 plus x square or x square plus 1. So we can write sin h inverse of x, sin h inverse of x. So plus C2, this is the constant of integration. So y is equals to sin h of root C1 x plus C2. So this is the required equation, or we can write y is equals to sin h of ax plus b. This is the required curve.